So as I was telling that this site, I will share the link over here. So you guys can go and watch all the things, which is very useful for you to understand how the electromagnetic radiation is actually. So this is visible, right? How this is going in a circular direction. That's why it is called as a right circularly polarized light, or if it is left side. So this is a superposition, like we have both the electric field and the magnetic field, and this green one is the blue one is our final one. That is a resultant of both the electric and magnetic fields. So this way you can understand it from the 3D views and the front views, and that's why we have used a arrow mark for defining our front view of the waves. So is there any question you want to ask? Because we still have 40 minutes in hand, so I can explain if you need 20 minutes in hand. So if you need me to explain anything.
Ma'am, in here hydrogen peroxide is available, H2O2. That is in bracket specified open
Book.
Open book. So I cannot understand here.
So actually H2O2 exists in 3 forms. One is cis form, second is trans, and third one is open book form. And all the 3 forms for the same molecule, it is having different point groups and different properties. So cis form, if I will try, that both the hydrogens are facing each other. This is cis form. And we have already discussed the point group for this cis one is because the C2 will be from here. Say, for example, C2Z. So it is belonging to C2V point group. The trans one would be having both the hydrogens facing the opposite side, right? So it would be having C2, but in Y direction, and it would be having a molecular plane. So you can go back and cross check. It would be having a molecular point group as C2H. Now the open book form. Open book is something like, if you understand the book, or you can consider a laptop. So laptop screen would be, the base would be like this way, and your screen would be like this way. Is this clear? So your oxygen-oxygen bond would be here, 1H here and 1H here. So this is only having a C2. If you will try to inculcate any plane into that, it is not going to happen because your one hydrogen is above that along the screen and the other is down. So it is not uniform. So it can't be having any other symmetry except the C2. Only the rotation is possible. That's it. That is 2 along the OO bond. That's it. So open book form, and the question was that this question actually came from the last assignment, where I asked whether this open book form of the H2O2 comes under chiral. Is it chiral or not? So we know that for chirality, the chiral point groups, it needs to belong to CN or DN, right? Right?
Okay, ma'am.
Sorry? So for chirality, point group should be belonging to CN or DN. Is this true or not?
It's true, ma'am.
Yeah. So now we saw that H2O2 cis form is giving us C2V. So it does not belong to CN or DN. So this is not chiral. The transform also is belonging to C2H, which does not come under CN or DN. So this also is not chiral. Now the open book form, if you will see here, it belongs to C2. That means C2 is nothing but belonging to CN, where N equals to 2. So this is a CN. So it should be chiral, right? Should it be
Right,
chiral?
ma'am.
So just looking at the point group, we understand that it should be chiral. But this is actually not true. So if I will draw here that open book form, the chiral also says that the mirror images should be non-superimposable. So when I have drawn, this is a mirror, and now I am drawing this. This of H will go here, this is going here. So now if I'll try to superimpose it, it would be non-superimposable. But we need to understand that this single bond rotation, this OO single bond rotation can happen very easily. And when this single bond rotation is happening, it is again giving us this same form as we started with. And therefore, when it comes back to the same form, both the mirror images superimpose with each other. Therefore, it makes it not chiral. So H2O2 open book form, even though it belongs to CN category, it is not chiral because of the single oxygen-oxygen bond rotation. Is this clear?
Clear, ma'am.
No. So this is what I was explaining in the starting of the lecture, that even if it belongs to C2 point group, it is not chiral because there is single bond rotation. And then we explained, then I talked about the amino acids, which comes under aliphatic, aromatic, basic, acidic. Everything is based on the R group. If R is your aliphatic, that belongs to aliphatic amino acids. If it is phenyl group or indole group, that comes under aromatic region. If it is having more than NH1 and NH2, that calls it basic. More than one COOH carboxylic group, that is called as acidic. If you have a polar substrate, that is CH2OH or something like that, that comes into polar amino acids. If it is comprising of sulfur or selenium, that comes under sulfur containing amino acids. And how to assign the L and D, we have already discussed. We have to apply the Kohn rule. Then we talked about the Kohn rule, like how the rotation from 1 to 2 to 3, anti-clock or clockwise, we can assign the L and D form. The assignment problems we saw. And then we were talking about the optical rotation of your light, that also we saw. So these were the topics that I covered in this lecture, the chirality and the chiral environment. So for chirality to occur, the chiral environment is required. And there I explained the enantiomeric axis. So you know, if you have one chiral center, it can give you 2 enantiomers, right? So it goes like 2 into n power. So if one chiral center is there, you will be having 2 enantiomers. Now, if both the enantiomers A and B are 50-50%, so that is not going to create any chiral environment, because whatever the amount of one is there, second is there, so it will counter cancel each other. Therefore, there would be any chiral environment present. That is called as enantiomeric axis we are talking about. So if any among the two enantiomers, if one is more compared to the other one, there that will be having enantiomeric axis, and therefore we call it as a chiral environment. So that what we explained. This is Murchison meteorite. That means from where the chirality concept comes into picture. When this meteorite strikes the earth and it was actually composed of many minerals and rocks and everything, but it was also having amino acids. So amino acids that I've already discussed, the 20 natural amino acids, besides it, there were many. So those amino acids actually started forming the proteins, the carbohydrates, our DNA, RNA structure. So from where the life actually started. So this chirality concept is that old concept. Then we talked about how the light and matter interacts. So that we discussed in detail. So how the light and matter interacts. So when we have generally, when there is no effect or the striking of the photon, ground state would be populated with the electrons. And when it is resting in the ground state and when I'm striking the photon with a certain energy, it starts excited. We say that electron goes to the excited state. It actually does not go anywhere. It is just the change in their energy. It is just the perturbation happens. So how light actually interacts? Because light is nothing but an electromagnetic radiation, which comprises of both electric field and the magnetic field. And here we know this is the electric field and magnetic field are perpendicular to each other. But compared to both of them, electric field is in a major content which interacts with the matter. That's why we consider only E value. And to understand that how electron density is getting affected, we know that there is a Schrodinger wave equation, which is H psi equals to E psi. H is nothing but the Hamiltonian operator, which when applied on a wave function is just to tell you about the probability of electron density in a particular orbital. So when Hamiltonian changes, when there is a perturbation because of the interaction of the light, the energy value changes. So it goes from the ground state to the excited state. So this is what we have given over here. Then again, this we have already explained that it is comprising of the two things, electric field and magnetic field. This is where when electric field strikes your material or matter, which is having electrons, this is the kind of electron redistribution happens. The charge density is going to redistribute. First, it was spherical or circular. Otherwise, it will take a different shape. So it will cause a polarizability, whether it is getting polarized because electric field is coming with certain charge. So that is affecting your electron density and that is causing the polarizability. So after that, whether the transition is allowed or not, that we understood from the transient dipole moment integral. So if this value is 1, then it is allowed. If it is not, that is 0. Then we looked into the interactions. Absorbance have already told you that how the concentration, if concentration is more, the absorbance of the light would be more. If the path length is more, the absorbance will be more. And if the transitions are having more epsilon value, that molecular property, more absorbance coefficient, then also the absorbance will be more. That we discussed, and then we talked about the white light, how to convert the white light into a plane polarized light, and how it affects a molecule, which is because the plane polarized is chiral. So whenever we have a molecule and we need to detect whether the molecule is chiral or not, if it rotates your plane polarized either in right direction or in left direction, that means your molecule is chiral. So this is what we understood, and this is what we covered. So does that help you in understanding a little bit?
Okay, ma'am. Now I understood.
Okay, great. So if you have any questions still, you can ask me. Otherwise, you can leave the meeting. I will be here till 10 more minutes. So thank you everyone for joining this live session. The things and the PDFs and every literature would be uploaded. You can go back and watch the videos again, and I'll be happy to answer your questions in the next live session. See you guys. Thank you so much.